Hello, in this modern OpenGL video, we're going to be looking at combining our light sources. So we've done directional lights, point lights, and spotlights. Brief overview of what they are. A directional light is a light that has a particular direction, aka it shines light in a particular direction, but it doesn't have a location and position. It's just infinitely far away from everything. Then a point light has a position, but it shines light in every single direction. Depending on what you're doing and what sort of game you've got, you could potentially have let's say the sun or the star as a directional light. But if it's more of a game that's, you can go into space, you can go around your star or get near it or whatever stuff like that, then you'll probably want it more like a point light. And the third one is a spotlight, and this essentially is like a lamp where it casts a light as a initial position and then a direction as well. So it's like a combination of the two. We've looked at all of them, but at the moment in these tutorials we've just been covering one at a time. We've either been commenting at code or modifying code to just show one, and realistically in a real game scenario or a 3D application scenario, you'll want multiple light sources. You'll want multiple instances of directional, point, and spotlight. You'll probably want to try and create your own really cool effects as well. So in this video we're going to be combining our three types of light casters. So the first thing that we need to do is go to the Fragment Shader for lighting. That's the only shader that we actually need to modify. So first of all, what we're going to do is, again, I've changed the way I am recording these slightly. Instead of zooming in like so, which degrades the quality, what I've done is just increased the text size of everything. If this is good, please do let me know, because the quality still retains high quality, but you can see everything. If you can't, if you prefer the old method, again, please do let me know so I can improve it. So first of all, we're going to do a hash define, and this is just going to be the number of point lights. And as usual, I recommend experimenting with these values. Try adding more point lights, try removing point lights, do stuff like that. It's a great way for learning. So for this, I'm just going to put 4. I'm going to have 4 point lights. For the material, diffuse specular shininess, that is all good. We're not going to be changing any of that. First of all, what we need is a directional light. And we need a directional light, a point light, and a spotlight. What I'm going to do is actually duplicate this struct and rename each one appropriately. So this will be a directional light, so DIR. This is going to be point. This is going to be spot. We don't need all of the the vectors and the floats that we've got in the directional light. We don't need all of these variables. So for the directional light, as you can remember, it doesn't have a position, it has a direction, it has a ambient, diffuse, and specular, but it doesn't have any of these float variables. So we can just remove this. For point light, remember, it doesn't have a direction, it has a position because it just emits light in every direction. We can get rid of the cutoff and the outer cutoff, but everything else we're going to need. And then for the spotlight, I believe nothing will be changing in here, because again, this is the structure that was created in the previous video, which was covering spotlights. So if we go down, we are putting a color, we got the fragment position, the normal, the texture coordinates. For the uniform, we are doing the V position, that's great. We're doing the material, but for the light, that's going to change slightly, because again, it's called directional light, so I'm going to call this DIR light. And now uniform, this is going to be spotlight. I'm going to create a spotlight, so spotlight. And finally, we're going to create one for the point light, so point light. And as you can remember, well, I'm sure you can, just above we created a hash define. So this is going to be an array of lights, so point lights, number. Even though we're creating multiple spotlights and only one directional light and multiple point lights, but we're only creating one directional and spotlight. You can create multiple directional lights. You can create multiple spotlights. That's totally up to you. Multiple spotlights, lamps, lights, lights on a stage, that sort of stuff. Directional light, you might have one like really strong one, which could be essentially simulating the sun, and then you might have just general other small lights. Again, imagine if you're just on an island and there are other factors at play that you can't really reach, so they're infinitely far away. So number of point lights, and what we need to do now is just create some function prototypes, because at the moment what we've been doing is just doing everything in the main. This has been okay for now, but we need a bit more flexibility with the way we're doing things. So we're going to do vec3 calculate directional light. Actually, no, let's just shorten it. Calc directional light, and this is going to take a few parameters. The directional light is the initial one. Then we're going to take a vector3 for the normal. We've explained the use of all of these different vectors and properties before. Again, we're just combining what we've done of the past few tutorials. The vec3, the view direction. And now I'm going to copy and paste this. And this, I think you can guess, this is going to be the spotlight, the point light method. And instead of dir light, it's going to be point light. Still going normal. And instead of a view direction, we need a frag position. So frag position. You know what? I could have kept that because we need a view direction as well. My bad. My bad. And finally, this is going to be the point light. No, I mean the spotlight. So calculate spotlight. This is going to be spotlight. Got normal, frag position, and view direction. That's all good. Now in the main, we're gonna actually not need all of this stuff. So what we're gonna do is, I'm just trying to think what's the best way to do it. I could start creating the other methods, copying and pasting stuff out of there. But you know what? I'm just going to remove it, because I think by removing it and making sure the new code is there, instead of trying to cut stuff out, put them somewhere else and making sure it's there, then it'll just cause more confusion. So in the main, what we're going to do is do vec3. This is going to be the normal. So we're just going to be normalizing in the normal. Then we're going to create a vec3 for the the view direction. This is going to be normalized between the difference of the view position and the fragment position. Frag, pause. I just had to check if it was recording. For some reason I thought it was, and I was like, oh, if it's not, no point me continuing. And now we need to do the directional lighting calculation. With this, we're just going to be calling the calc directional light method. So we're not going to be doing much code in the main. Again, we are trying to, because we're adding more stuff to it, it's becoming like another C++ project, because we are abstracting it out into different methods, so we can reuse this code when and where we need to. So vec3 result, and this is going to be equal to calc directional light, and this is going to take the directional light variable, the norm that we just calculated, and the view direction. Now we're just going to loop over the point lights and factor them in. So int I equals 0, I less than, I'll just copy and paste it from here, just be easier this way, I plus plus, and now it's going to do result plus equals calc point light. Again, what we're doing now is adding on the effect of the different point lights to our result, because again, this lighting is affecting our particular object. This is the way it's done. So calc point light. I'm going to do point lights. Frag position. Okay. So what we're going to do now is do the spotlight. So result or factor in the spotlight plus equals calc spot light, and this simply takes in the spotlight variable. Spotlight. Have you seen the movie Spotlight? It was okay. I was hoping that would be better than it was. Another movie with Michael Keaton coming out. Is it Founder? Something like that. The one about McDonald's. That looks really good. I'm not a big fan of Michael Keaton, but that movie does look really good. Color equals vec4 result comma 1.0. Again, this is all stuff we've done before, and we're just abstracting it out now. So what we need to do now is we're going to, you know what, I'm just going to copy and paste these. It'll be easier than me typing them out again. So if I go here, and let's do the same with here, and then let's do the directional light calculation. So in here, what we want to do is vec3 light direction, and this is going to equal to, sort of regretting not copying stuff now, because again we've done literally all of this before, but I will just quickly go through it. Oh damn it. Yeah, the reason I've explained before, but the reason it's the negative light direction is because we're not doing it from our object, we're doing it from the light. So instead of the way we're looking, or the way the object is looking at the light, it's coming from the light. So that's the reason why it's flipped. And so when if we float, this is going to be the diffuse shading. So diff equals max dot normal light direction 0.0. Now we're going to be calculating the specular shading. So vec3 reflection direction equals reflect negative light direction normal float spec equals pow max dot view direction reflection direction 0.0. And then finally we just need to add the material shininess dot shininess. Now we need to combine the results of vec3 ambient equals light dot ambient times by vec3, and this is going to be the textures diffuse and the texture coordinates. So material dot diffuse text coords, we're going to do vec3 diffuse equals light dot diffuse times by diff times by the vector 3 of texture. You know what, it's essentially the same as this. I'm just going to copy and paste this to save some time in DD. I'm just going to make sure it is the same. So texture material dot diffuse text coordinates, that looks all good. You know what, the specular calculation or the specular vector is very similar. So specular instead of light dot diffuse is light dot specular. Now you timed it by spec, which is we calculated above right here. Vec3 texture material, instead of diffuse it's now shininess. material.shininess. Now we're going to do material.specular in the texture coordinates. Oh, damn it, what have I done? I didn't mean to go apply that. Okay, so specular, and finally we just need to return calculation, which is ambient plus diffuse plus specular. And now we need to calculate the point light. So we can, you know what, I think a lot of this will be valid, so I'm going to copy and paste this into the point light, add, change, remove what we need to. So if we go to the light direction, the normalizing is going to be between the light position and the difference between that and the frag position. And now for the diffuse shading, this isn't changing at all, which is good. For the reflect direction, not changing at all. For the specular, yeah, that's looking all good. And the only thing we need to do in between the spec calculation and the ambient, diffuse, and specular is do the attenuation. So attenuation, so float distance equals length light dot position minus frag pos float attenuation, which is basically the fallout of light, because the further you get away from, or the further an object gets away from a light source, the less effect that it has. So that's essentially the attenuation. And you modify this to have more of an effect the further it is, or less of an effect. So 1.0 f divided by light.constant, not constant, plus light.linear times by distance, plus the light quadratic, which is above, if you scroll up, times by the distance squared. So distance times by distance. Again, there's quite a bit going on here, and we haven't just copied and pasted it. I just want to make sure I got it correct, because sometimes I do mix the pluses and the times. So light.constant plus light.linear times by the distance plus light quadratic, and this is multiplied by the distance squared, so distance times by distance. And the ambient calculation does not change, but what we do need to do before is factoring the attenuation by doing ambient times equals attenuation, and I think you can guess, we just do the same for diffuse and specular. So diffuse and specular, and now we need to do the spotlight. Again, I'm just going to copy and paste this, because we'll most likely be adding more to it, but we'll need most of it. So if we go to the first line, the light direction, this doesn't change. Still the difference between the light position and the frag position. For the diffuse shading, doesn't change. For the specular shading, from what I can remember, this doesn't change, but I just want to have a quick look at it. So view direction, reflection direction, and the material shininess, that's all good. Now the attenuation, this shouldn't change either, but again, it's always best to go over it. So we add in the light linear times by the distance. That looks all good to me. But before we do this, before we get onto the ambient, diffuse, and specular vectors, we need to do the spotlight intensity. So for that, float theta equals dot light direction normalize, and this is going to be the negative of the light direction. Again, we'll explain why it's the negative, because we're looking at it's not from us, it's from the light. Hence we need the negative direction, because we know one direction, and to get the opposite direction you just negate it. So float theta, we need to do the epsilon now. So float epsilon, not epsilon, epsilon equals the light dot cutoff minus the light dot outer cutoff. They finally factor in the intensity or calculate the intensity. So float intensity equals clamp theta minus the light dot outer cutoff divided by epsilon. Sounds something sci-fi. I think it is, isn't it? Epsilon, the ship. Can't quite remember. I'll have to Google it in a second. Epsilon. So for the, again, we just need to factor in the intensity. So we just do time by intensity. We've covered all of this before in the previous videos. We are just combining it all together. And now we're done. I'm sure there's going to be errors because there's quite a lot of code in here. So we'll get to that when we start compiling it. So let's just save it. Go to the main.cpp. And what we need to do is, I'll just close that. Scroll down. Actually, one second. This is just something I want to make sure. It's in the fragment shader, yeah. Okay, that's fine. For some reason, I just felt that the code in here in terms of the font size just seemed bigger. But no, it's just me. Okay, so if I scroll down, keep scrolling, we need the lamp shader. So comment this back in, or uncomment it. Uncomment it. And after the cube positions, because we've got multiple point light positions, we're going to do glm vec3, and this is going to be called point light positions equal to actually I don't like this like this. Oh, I'll put a comment here. Positions of the point lights, semicolon, and this is going to be glm vec3, comma. And you know what? I am going to copy and paste this because there's going to be 4 rows. Last one, we don't need a comma. And for this, put 0.7f. Again, modify these values, see how far you can take them, how close you can take them to the cubes, the objects that we got in our scene. That's the best way of learning. The experimenting, so 0.2f, 2.0f. This is going to be 2.3f, negative 3.3f. This is going to be negative 4.0f. Going to be negative 4.0f, not 40f, 4.0f, 2.0f, negative 12.0f, 0.0f, 0.0f, and negative 3.0f. So let's scroll down, and we don't need to change any of this. The only thing we need to do is uncomment out the light vertex array object, because remember, we need it now, we are using it now. And we're not going to be doing anything more in here, or we are, but it's actually all within the while loop now. So if I just keep scrolling down, and to the point where we get to where we're using the lighting shader. So what we're going to be doing is we'll create the view position location first, because there's going to be quite a lot of code in here, in all fairness. So the view position location, very simple stuff. We've done this before, and we'll get, because what we're going to do, we're going to group them together, the code together. So we've got the view position location, and now we just need to set the material property. We'll just put all of that up top. So now we need to do the directional light. So for the directional light, we are realistically going to need some of this. So I'm just thinking, what's the best way to do? Should I just recode it, or should I actually just copy and paste? I'm just gonna recode it. It's gonna be a bit long, gonna be one of those sort of long ass processes, but one of those things. So GL, this is gonna be the directional light first. So GL uniform 3F, and this is gonna be GL get uniform location, and this is going to be the, I don't need semicolon there, lighting shader dot program, and this is going to be dir light. Remember, this is based on the variable that we created within our shader dot direction, and for this we're just going to put values of negative 0.2f, negative 1.0f, and negative 0.3f. And you know what, I'm just going to duplicate this for the directional light to save some time. This will change to ambient now, ambient. This will change to diffuse. This will change to specular. And this will be changing to 0.05f, 0.005f, and 0.05f. And for the diffuse, it's going to be 0.4. Again, these are just arbitrary values there. Change them, try and see what you can do and get different results, because that's what you're going to have to do with your game, 3D application, or whatever you create in the future. And this is going to be 0.5, 0.5, not 51.0. But what would happen if I did like that? Try it. I do recommend, not in a real life scenario, but in here, just honestly see what happens. It's always cool to see like the result of something funny or dodgy. So now what we're going to be doing is the point light. So for this, I will write it out again. So GL uniform 3F, GL get uniform location, and inside of here we're going to do lighting shaded up program, point lights 0 dot position, and out of here we're going to be doing, then it's the position. So we already have a, what's it called, an array up here that we just created, this right here. So we'll be using that. So what we'll be doing is point light positions 0 dot x. I'm actually going to copy and paste that, and just change this to a y, change this to a z. And now what we're going to be doing is, should I, yeah, I'll copy and paste it. I think that'll save me more time than rewriting out the entire thing. So the position, we're going to be affecting the ambient now. So for the ambient, we don't need these anymore. And this is going to be 0.05f, 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 0.05f. Copy and paste this, and this is going to be specular, and this is going to be 0.8f. It's actually all going to be 0.8f. Quite a lot of it will be the same for the different point lights. Obviously you can change them, and I recommend that. Make different point lights as different as possible to see the different results you get, and then you can try and identify, oh, this is this one in the code. It'll be a really cool and useful way of learning. So the next one is this wasn't specular. I was thinking usually I do ambient, diffuse, specular. No, this was diffuse. The actual values were fine. It's just I messed up on the naming. This is 1.0f. And now we're going to do the constant. So I'll just duplicate that, change this to a 1f. Usually I'm looking at it, I'm just like, well, I've only put one value, but why is it not working? It's got to be 1f, and it's going to be 1.0f for the constant. Copy and paste this. Change this to linear. And this is going to be 0.09f. And this is going to be quadratic. It's almost like erratic. Quadratic, 0.032f. And that's the first point light done. You know what? I think it's best if I comment this. So directional light will be easier. Point light 1. And what we're going to do is duplicate this. Luckily, pretty much all the code is going to stay the same. So this will change to point light 2, and one of the differences is going to be, this is now going to be 1, because it's the second point light in the array. Just remember back to C++ basics, arrays and a lot of stuff in computers start at 0. So instead of doing point light position 0, this needs to be a 1, but the ambient is staying the same, the diffuse is staying the same, the specular is staying the same, the constant, the linear, and the quadratic. And as a matter of fact, it's actually staying the same for all 4 point lights. So we can really speed through the point lights, because otherwise it would have been so annoying if we had to change so much code every single time for the point light. In this particular example, that is. So 2, 2, 2. And now what we need to do is change these. And now finally, do the last point light. That's for the point lights. We still need to do the spotlight as well. But there's only one of those bad boys, so that should hopefully not take too long. And now we just need to do the spotlight. Again, I'm gonna just rewrite it because I think it's gonna cause less confusion and less errors. I'm interested to see how many errors we get after this, because again, when you're doing a lot of code, especially in a tutorial, you always get errors, or at least I always do. GL get uniform location. And in here, it's going to be lighting, shader.program, comma, spotlight, dot position. Again, if you look back to our vertex shader for lighting, you'll see why we're using these names, because that's what we put as our variable. So light, spotlight, dot position, and this is going to be the camera. Dot get position, because we're just gonna attach it to our head, basically the camera. I need to change this to a Z, this to a Y, so X, Y, Z. And now we need to set the direction, and this is just going to be the front. So get front, and I need to change this to front. Not front, direction. From the camera it's called front, but in terms of what spotlight is doing, it is the direction. So now we need to do the ambient. Just copy and paste this. I'm going to change this to ambient. Ambient, and it's just going to be 0.0f for all 3 values. 0.0f, 0.0f, 0.0f. Now we need to do the diffuse. This is going to be simple. 1.0f, We are nearing the end now. A lot of code, I know, but just be patient and the end result will be worth it. At least I hope it is. So diffuse specular 1.0f, that's fine for the constant. Remember, we only want 1f. And this is going to be constant. It's going to be 1.0f, but we only need the 1. Now we're going to be setting the linear and the quadratic. So duplicate this line, do it twice, change this to linear, and the value is 0.09f. And now the quadratic, which is very erratic, 0.032. And now we just need to do the spotlight cutoff and the outer cutoff as well. So spotlight, this is still a 1f. I mean, yeah, a uniform 1f because there's only one float value. Cut off, a great way of knowing what type it is. Just go into the shader and you'll see based on the variable that you're trying to set. So we're going to do GLM, cos GLM, radians, and in here is 12.5f. It's the same values as we did before. Actually, we're gonna, just change it slightly. So 12.5f instead of 17.5, we'll put 15.0f. And for the name, we need to be outer cutoff. I assure you, we are now nearing the end. Wow, we still got all of this code which we don't need anymore. So from just above the view to where we finished our spotlight stuff, because again this is remnants from when we just only had one type of light and it was called light, so we get rid of that. So if we keep scrolling down, we need to comment back in the shader. And I need to comment back in the deleting of the vertex arrays of the light vertex array object, and I'm just trying to think, what am I missing? That's what it is. We've looped through our box array and we have created all the different boxes, and we've got a lamp shader, but remember we've got multiple point lights, so we just need to create a loop for that. So after the binding on the vertex array or unbinding it, and before we swap the screen buffers, we need to do GL bind vertex array, and we're just going to be doing this for the light vertex array object. I've already done it here. I can actually just get rid of all of this code. Actually, we still need the rest of it. This is like the start and the end, but now in between here we're going to do for GLU int 1 equals 0, 1 less than 4, and now we're going to do model equal GLM column 4x4 matrix. It's all simple stuff what we've done before. Model equal GLM translate, and this is just going to be translating the model, and then the vector for it is going to be point light positions, then the iterator, which is called I, and now we're just going to make the cube a little smaller as we have done before, equal GLM scale, and what am I? That's fine. I have sort of messed up. I'll explain in a second. I've just deleted some code which is actually relevant to this, because again we had we had a light, but we also have point lights as well. But again, I'll fix that. That's a minor fix. So let me just finish this. So scale, model, GLM : vec3, 0.2f. Now we're going to do GL uniform matrix 4 floor value because it's a 4x4 matrix. I need the model location. 1 GL underscore false, not GL underscore add or alpha. False GLM : this is going to be the value pointer, and this is going to take the model. GL draw arrays, GL underscore triangles. For this, it's going to take 0, 36. And what I messed up was here. What I did was I actually sort of just, this code needs to be here as well. Because again, this is a separate piece of code, and we also need this here. And the final piece of the puzzle, in between here, we still need the GL draw arrays, which we've already got it here. I'll just copy and paste it. And now we are actually ready to run. How many errors do you think we're going to get? I recommend placing your bets. And 5, 4, 3, 2, 1. Okay, let's see if we got 0 compilation errors. And I've been having this error since I've reinstalled Mac. It's not specific to this project, but in other projects. Again, if anyone knows how to fix this, please do let me know. But what just happened there? Oh yeah, I think it's because I looked somewhere totally else, but it's working. We got our multiple light sources, 4 of which are the, what are they called, the point lights, and 1 is just a regular lamp. But we have, I actually recommend, see if you can figure out which one's the point light and which one is the lamp. And we have the spotlight that is attached, and we also have the general directional light. And you might be thinking it's sort of hard to tell which one's which, and generally in the real world, I'm looking around in my room now, it's hard to see, oh, this wall that's illuminated, where is the light coming from? Obviously most of it's from the bulb, but the TV on, there's monitors on, there's lights coming from LED indicators that are charging, LED indicators of devices that are charging, etc, etc. So it's all having a effect on everything around us, and this is how it works in the game. And it looks cool that we've got obviously our world and we're further away, so our spotlight really isn't affecting it anymore, but it's still there. And as we get closer to it, like we would have like a real torch on a helmet or in our hand, it starts affecting the object, and it's cool to see how it does affect it combined with the other light sources. So that's it for combining the directional, point and spotlights. I know it's been a long video, a lot of code, but a lot of it we've already done before. If you have any questions, feel free to post them on our education platform, sonarlearning.co.uk. There'll be a link in the description, plus there will be a link in the description to the source code from all of these videos. It'll be a GitHub link, plus there'll be links to learnopengl.com and open.gl, which these tutorials are based on. The fantastic ways to enhance the experience from these videos. Check these videos out, have a look at their written tutorials, because the written tutorials go in more depth, they use great diagrams, and they got more tasks to do as well. If you like this video, please give us a thumbs up, hit that subscribe button and leave us a comment, and as usual, thank you for watching, and I hope you have a great day.